Once again, you are welcome to our online lesson for mathematics, and today we are going to consider a very interesting topic when it comes to calculus, and that is limits of function. So we are going to look at the topic limits of a function or limits of functions. Now let us do some experiment over here. You realize that when you started learning the concept of functions, we said that functions are defined in the form of f of x, g of x, h of x, and so on and so forth. And all functions have a rule. The rule can be a polynomial rule. It can also be rational, or it can actually be exponential, and so on and so forth. So if I have a given function as f of x equal to x plus 1, they can actually ask me to find what f of 2 may be. When it happens that they ask you to find f of 2, all that you need to do is to substitute your 2 in place of x, because f of x is equal to x plus 1. So if they say f of 2, then it means the x value is 2. So that is going to be 2 plus 1, and that will give us an answer of 3. Automatically, from functions, we learned that you have two forms of values. We have the domain and we have the codomain, or we have the elements and their corresponding images. So it means the x represents the elements in the domain, whilst the y represents the elements in the codomain. So ideally, when we have f of x equal to x plus 1, it is the same as you saying y is equal to x plus 1. So mathematically, we can say that the f of x symbol is the same as the y symbol. But what type of function do we have here? This is a linear function. In another situation whereby we may have g of x equal to, this time around, I have x plus 1 all over x plus 1. Now, ideally, this is a rational function. And with this rational function, we always have an undefined solution. So over here, you can say that where x is not equal to 1, and I believe you've seen that whenever they give you any kind of rational function, they always give you the undefined value, and therefore that undefined value should be out. Hence, if I have f of x plus 1, g of x is equal to x plus 1 all over x plus 1. Now, ideally, you learned some time ago that any number divided by itself gives you a final answer as 1. But in this circumstance, if I have g of x equal to x plus 1 all over x plus 1, it doesn't mean this is the same as 1, because at this point, hold on, over here I have to change something. Here must be -1, where x is not equal to -1. Sorry for that. So g of x equal to x plus 1 all over x plus 1, it's not all the case that it's always going to be 1, because in a situation whereby I substitute, or I want to find g of -1, you realize that I'm going to obtain -1 plus 1 all over -1 plus 1. Now, -1 plus 1 gives us an answer of 0 divided by 0. Now, 0 over 0, ideally, what's the value?
Undefined.
It is undefined. So, meaning the value does not exist. So, that's why I'm saying that g of x equal to x plus 1 all over x plus 1, even though it is 1, because when you use the idea of factorization, this whole factor can do away with the factor they're giving you 1. But in this situation, it is not always going to be 1. So if we should try to draw the graph of this function, let us see a simple graph of this function. A simple graph of this function. So this is my y-axis and that is my x-axis. So if I have the coordinates here, I have 1 here as a y value. I have -1 for x, +1 for x here. Now, it means at any value that you substitute into this function, which is g of x equal to x plus 1 all over x plus 1, now you get the y value to be 1. But when it happens that it gets to -1 for x, when it gets to -1 for x, there's going to be a gap because there's no solution that exists. There's no solution that exists at when x is -1. So it will jump and then move to the next. That's why we have this gap here, because when x is -1, the solution is what? Undefined. My people, are you with me? Are you with
Yes,
me?
please.
So
Yes, sir.
So this is where the whole idea of limit of function is coming on board. This is where the idea of limit of function is coming on board. Limit of function is coming on board to determine the value of a given function at the point whereby the solution does not exist. You know, the word limit, when it comes to English language, then it means we are saying how far can it approach or how far can it go. So ideally, the symbol we use is LIM. So we are going to look at limit of g of x as x approaches what value? -1. What then would the whole function approach? So if we find the limit of g of x, which is our function, which is here, as x approaches -1, then what is going to be the value of the whole function? Now, from the graph that we've had here, you realize that as x approaches -1, either from the left hand side or from the right hand side, automatically it should give you what answer, because you know that if you have a straight line and they say find the limit of a given function, all that you need to do is that you have to trace it. You just have to trace it. So maybe if I want to find limit of g of x, which is x plus 1 out of x plus 1, as x approaches, this time around I'm not going to use -1. Let us use 2. If I use 2, it means I have 2 here. So ideally, when you substitute 2 here and you substitute 2 there, you are going to get 2 plus 1 divided by 2 plus 1, which is going to be 3. It's going to be 3 over 3, right? 3 over 3 is the same as what answer, please?
1.
It's also the same as 1. So it means that everything boils down to we getting the answer as 1. So limit of g of x as x approaches -1, ideally we are estimating that it's supposed to be positive what? 1. Now let us do another operation here, still using the idea of g of x equal to x plus 1 over x plus 1. And we are saying we want to find limits of g of x as x approaches, this time -1. So approaching -1, then it means what are the possible values of x approaching -1? It's either x is equal to negative 1.00 or negative 1.001 or negative 1.00001. All these values, when you approximate it to the nearest whole number, actually is the same as negative 1. Do you agree with me?
Yes, please.
So let us look at something. So if this time s value is negative 1.00 or negative 1.001 or negative 1. So let's substitute it. Please get your calculator ready because we are doing it together. So if x is that, so we have chain of negative 1.001. Then we are going to have negative 1.001 plus 1 all over negative 1.001 plus 1. Please operate this on your calculator for me and tell me the answer. Operate this. The answer is 1. Now, let us take this one also. So we are having g of x s being negative 1.00001. So we are finding g of s altogether. So we have negative 1.00001 plus 1 all over negative 1.00001 plus 1. Please operate this one also for me and tell me what the value is.
1.
It's also 1. So it means we've taken values which is to the let's say to the left hand side of negative 1. Let us take another number which is also close to negative 1. So what are some of them? To the right hand side. So to the right hand side, you know, if this is your number line and you have negative 1 here, negative 1.00, those numbers are on the left hand side. All these numbers that I chose, they are on the left hand side of negative 1. How about numbers to the right hand side of negative 1? So it means 0 will be here. Do you agree that 0 will be here on the number line?
Yes, please.
Okay, so what will be some of the possible numbers very close to negative 1 on the right hand side? So this right hand side, that's left hand side. I've considered some numbers on the left hand side. So on the right hand side, what are some of the possible numbers which will be very close to negative 1? It may include x equal to, let me give you one example, 0. Negative 0. Negative 0.99999, or it may include negative 0.99, or it may include negative 0.9 alone. Just that. I believe you know that when you approximate this number to the nearest whole number, it still gives you negative 1. Do you agree?
Yes, please.
Okay, so let us use these numbers to substitute in there, and then let's find out the result. So just help me out with your calculator. So if you should find g of negative 0.99, then that is going to be negative 0.99 plus 1 all over negative 0.99 plus 1. Please, what answer are you getting? When you simplify it with your calculator,
1.
you are getting 1. So let us take another number which is to the right hand side of negative 1. So we have g of x, which is negative 0.9. Let me use just that one, equal to negative 0.9 plus 1 all over negative 0.9 plus 1. What answer are we getting?
We get 1.
It's also 1. Good. So what it means is that even though for g of x equal to x plus 1 all over x plus 1, when you find the limit of g of x as x approaches 1, the answer is equal to 1. But when g of x which is equal to x plus 1 over x plus 1, sorry, here is negative 1. But for g of x which is equal to x plus 1 plus x plus 1, when x is equal to negative 1, g of x is undefined. Please, are you clear with what I've written there? Even though for g of x equal to x plus 1, the limit of g of x as s approaches negative 1, s equal to 1. But when g of x is equal to x plus 1 all over x plus 1, as x equal to negative 1, g of x becomes what? Undefined. Do you agree with me? Do you agree with me, please?
Yes, sir.
So the whole idea of limit of a function is that it actually tells you the exact value the function gets to or approaches when the function actually in sense does not exist at that number. Again, limit of a function actually tells you what the function attains or exists at one point, but when it comes to when the number is actually given, it does not exist at that moment. That's where the idea of limit of a function comes on board, and that is simply the beginning of the concept of what? Calculus. That's the beginning of calculus. So limit of a function is a tool which is used to learn calculus. It's a tool used to learn calculus. So again, limit of a function is simply a tool which helps you to determine how far a function exists at a given point. How far a function exists at a given point. That's the whole concept of limit of a function. That's the whole concept of limit of a function. So therefore, as I said early on, we will be seeing symbols like lim, which means limit of a function, let's say f of x, as x approaches a given number a. What does the function approach? What does the function approach? That's the whole idea here. Please, are we all clear so that we can go detail? Or any question? Okay, I'm saying that the whole idea of limit of a function is simply testing how far a given function exists as it approaches a given number. The limit of a function, how far it exists as it approaches a given number. That is how the limit of a function comes on board. I can give another example. To explain it further. Are you okay?
Yes, please.
All right. So let us go on to when we are given a function, a simple function like find the limit of, let's say, x plus 3 all over x plus 2 as x approaches 1. Even though this function, as we see here, the x plus 3 over x plus 2 is a rational function, even though this function as we have there's a number for which that function does not exist. What number will it be, please? Negative 2. It means when you substitute negative 2 in here, it makes this function undefined. But at this point in time, the value of x that we need to substitute is not -2. So it means this function should automatically exist at that point. So all that we need to do is that, what does that function give us? Then it means that's going to be 1 plus 3 divided by 1 plus 2. Hence, the answer that we're going to obtain will be 4/3. So it means the limit of x plus 3 all on x plus 2, as x approaches 1, the answer is 4/3. The answer will be 4/3. So it's all about you plugging in the value of x in there to get your answer. Another example, to determine the limit of x squared minus 2 as x approaches 1, what then would the function approach? Per this function, what type of function do we have here? X squared minus 2. What type of function is it, please?
It's a quadratic function.
It's a quadratic function. And when it comes to finding the domain of a quadratic function, you learn that quadratic functions do not have undefined solutions. Do you agree?
Yes, please.
So in other words, finding the limit of x squared minus 2 as x approaches 1, all that you need to go ahead is to substitute the value of 1 into the function, and that will give you 1 squared minus 2, and the final answer will give us -1. Sorry, 1 squared minus 2, and the final answer will give you -1. So it means that the limit of x squared minus 2 as x approaches 1, we are going to get an answer of -1. But let's take another example whereby sometimes there is a need for you to remove what we call the discontinuities. Let's take another example. So we have a perfect example as limit of x squared minus 1 all over x minus 1 as x approaches 1. What would the function approach? Now, per this example, what type of function do we have here?
The numerator is a quadratic function.
And the denominator
Linear.
is a linear function. So you have it in a fraction form, isn't it?
Yes, please.
So functions which are written in the fraction form, they are known as rational functions. Functions written in a fraction form, they are known as rational functions. And for most rational functions, they do have undefined solutions. So how would you determine that the rational function will have undefined number? The undefined number will be taken from the denominator. So in other words, what number do you think, when we substitute into this function, will make it undefined?
When you equate the denominator to 0, you have 1.
Okay, so it means when s value is 1, automatically this function shouldn't exist, isn't it?
Yes, please.
And they are asking us to find the limit of this function when the value approaches 1. Meaning it is not actually 1, but it must approach 1. It should get closer and closer to 1. Therefore, what answer are we expecting the function to have? And that is another thing altogether. So in this case, what are some of the possible values closer to 1? Yes, what are some of the possible values closer to 1? What do you think they are?
0.999.
So you have 0.999 as a possible value. Even you can have 0.9 as a possible value. You can even have 0.999. Now these numbers that you've given to me, when you take it on the number line and 1 is here, 0 is there, then it means that these numbers are on the left hand side of 1, isn't it? But they are still approaching 1. How about numbers to the right hand side? What are some of the possible numbers to the right hand side of 1? They are close to 1. They are not 1 though, but they are close to 1. We have what?
1.009.
So 1.0001. It's a possible value. 1.00001 is a possible value. Or then 1.00001. These are all numbers very close to 1 from the right hand side. And what you give me up here, they are numbers close to 1 on the left hand side of 1. Then in this case, please just take your calculator and then let's do just 2 of the experiment. We are going to use this and we are going to use this. And let's see what the number approaches. So if we find limit of, you know what we did early on, we're actually substituting the exact values. We're substituting the exact values, but this time we are not going to substitute the exact values. So this time around, what if we have it as f of x equal to s squared minus 1 all over x minus 1, and we find f of 0.999, and then we have 0.999 all squared minus 1 over 0.999 minus 1. Please operate this on your calculator for me and tell me what the answer gets to.
The answer is 1.999.
The answer is 1.999.
999.
Okay, so this is what you've obtained, right?
Yes.
So let us take another one. So we are using another one, which is when this time of time f of x is 1.0001. So we have 1.0001 all squared minus 1 all over 1.0001 minus 1. Please operate this one also on your calculator for me. What answer are you getting?
2.0001.
So ideally, to the nearest whole number, what does this approximately give us?
2.
How about this one? Approximately, what does it give us?
2.
So it tells you that having limits of x squared minus 1 all over x minus 1 as x approaches 1, what does the whole function approach? Yes, based on the experiment that we've done here. What does it approach? What number does it approach?
2.
It approaches 2. The whole function here approaches 2. Please, do you agree with what I've done here? Before I'll show you algebraically how you can get the same answer as 2. Please, do you understand what I've done here?
Yes, please.
The guys, I'm not hearing from you. Do you all get it before I move on?
Yes, sir. Yes, sir.
All right. So this is what it means. The limit of x squared minus 1 over x minus 1 as x approaches 1. Now we've seen that the actual answer is 2. But why is it 2? Now When you substitute the actual value of 1 in here, the whole function becomes undefined. So it means that within this function, we have what we call a removable discontinuity. A removable discontinuity. When you substitute the actual value of 1 in here, it will make the whole function undefined. So there is a factor that you need to remove out of this function so that it will give you the answer as 2. Now you've learned factorization, isn't it?
Yes, please.
So it means we having x squared minus 1 all over x minus 1, we can equally write it as limit x squared minus 1 in a factor form. What do we have? In a factor form, what do we have? Yes, what's the factor for x squared minus 1?
X
Mm-hmm.
minus 1
Times.
plus 1.
Thank you.
X
So
plus
because this is difference of two squares, all divided by x minus 1 as x approaches 1. So ideally, x minus 1 here can do away with x minus 1. Do you agree?
Yes, please.
So it is
Yes,
left
sir.
with limit of x plus 1 as x approaches 1. And at this point, whatever we have here as a function does not have undefined solution, isn't it? So what must we do to get our answer?
We substitute 1 in place of x.
We substitute 1 in place of x. So that's going to give us 1 plus 1. And that's the answer 2. And that's what we see up here. That's what we see up here. My people, are you with me?
Yes.
Yes, sir.
Any question before I bring another example?
Yes, please.
Okay, I'm listening.
Please, with the factorization process,
Yes.
can you decide to factor out x?
Can you decide to
Okay, I
factor?
think it will not work.
Yes, you can factor x out because
Yes,
x is
yes,
only found in the first terms, not the second term.
yes.
Yes, please.
Mm. Thank you.
You're welcome. Any other?
No, sir.
Okay. All right. So let me bring in another example. Let me bring in another example. This time around, I have it as this. So try this for me. I just want you to try this for me. Limit of the function 2x squared plus 4x plus 5 as x approaches 2. What will the answer be? Try it for me. Then that's number 1. Number 2, I have it as this. Limit of 9 minus x squared all over 3 minus x as x approaches 3. What will be the answer? Just try it for me. Yes, has anyone finished? So that's You share your answers with us.
Yes, please.
Okay. So can you tell us your values? What did you get for the first one?
This is the first one. I had 21. Then the second one, I had 6.
Yes, my guys. What are you also obtaining?
Say the same thing.
You get the same thing. Okay. So in the first place, I want a third confirmation before I move on. Yes, third confirmation, please. Do I have a third confirmation? Okay, so let's move on. So ideally, before we work out limit of this function as x approaches 2, you have to analyze what type of function it is. So for 2x squared plus 4x plus 5, it is a polynomial function. And what type of polynomial function? It is specifically a quadratic function. For quadratic functions, they do not have undefined solutions. So therefore, getting the limit of this function as s approaches 2, you just substitute the value of 2 into the function, and that's going to give you 2 multiplying 2 squared plus 4 multiplying 2 plus 5. And then the final answer, I believe it's giving us a 21 as we see here. We have 4 times 2, which is 8. 8 plus 8, 16. Then, oh, sorry, 5. Then 16 plus 5, that will give you 21. When it comes to this kind of function, we have 9 minus s squared all over 3 minus x. And I said, what type of function do we have here? A fraction. And what?
Rational function.
Rational function. Very good. And for most of the rational functions, they do have removable or they do have undefined solution. And when they have undefined solution, you just have to analyze it. Does it contain a removable discontinuity? If it does, then you need to do away with that before you do your substitution. So if you analyze it carefully, you realize that the numerator is a difference of 2 squares value. The denominator is a linear function. But 9 minus x squared, you can get a factor of 3 minus x in there. So it means you need to go further and see that this function can be written as limit of 3 minus x multiplying 3 plus x all over 3 minus x. And hence, as x approaches 3, and hence 3 minus x will do away with 3 minus x, and we are going to be left with the limit of 3 plus x, 3 plus x as x approaches 3. And for that matter, we've gotten a simplified function which we can easily substitute our value of x in there, for which that function is not defined at a point, and therefore that will give you 3 plus 3, and the final answer is 6 as it was given here. Please, are we all okay? Are we all okay, please?
Yes, please.
Alright, so at this point in time, since we've known what the limit of a function is, then we have to know something about the theorems of limit. So we are looking at limit theorems. So limits theorems. Now, when we say a theorem, what does it mean to you in your own small way? What does a theorem mean? Yes, what does it mean to you? What is a theorem? What is a theorem to you?
A theorem is a mathematical statement that has been proved.
Wow, that's so wonderful. That's a perfect answer. So it's a mathematical statement that has been proven to be true. That is what a theorem is. So when we consider theorems under limits, then it means that they are statements that have been proven to be true when it comes to the concept of limits. So one major theorem of limits is this. If you find limits of a constant number, let's say k, as x approaches any given number, the final answer is still the constant number. Limit of any constant number may be k. As x approaches any number at all, it still gives you the answer as k. Please, does it make sense?
Yes, sir.
Okay, let me go further to explain it. For instance, what is the k representing? The k here stands for what? The k here stands for what? When I started the whole idea of limits, the k stands for what? Yes, the k stands for what, please?
A function.
The k stands for the function. So the k is the function. And I said the function, which symbol can we also use to represent the function? It is either f of x or g of x or what? Another symbol for that is what? Yes, another symbol for it is what? If not f of x, g of x, h of x, what is the other single variable we can use to represent it?
Is it y?
It is y. So all this is equal to y. So this is what the statement that I've made here means. This is what it means. If you have y equal to, let's say, 3, then it means limit of 3 as x approaches any number at all, the answer must still be 3. Limit of 3 as x approaches any number at all, the answer is still 3. It will never change. Let me explain this with a graphical statement. So this is my y-axis, that is my x-axis. Now, we said that 3 is representing y, isn't it? So it means I have 3 here. Do you agree?
Yeah.
Good. So now, let us draw y equal to 3 is a straight line. Sorry. Y equal to 3 is a straight line. So that line will pass through 3. Do you agree with me? Do you agree with me that that line will pass through 3? Y equal to 3. This is the line.
Yes, please.
So y
Yes,
equal
sir.
to 3. Now we said that limit of 3 as x approaches any number. And this is the x values. So let's take it that when x is equal to 1, ideally, graphically, when you come back to the graph, 1 can be here, 2 can be here, 3 can be here, 4 can be here, 0 is here, -1 is here, -2 is there. So if you should trace it, if x approaches 1 and it is here, if you trace it towards the graph, what number does it hit? On the graph, what number does it hit?
1.
3.
It hits 3. Look at it carefully. When we trace it, this is the graph that we've drawn. When x, so limit of 3 as x approaches 1. The answer is still giving me 3 because from the graph, when you have 1 and you trace it towards the graph, it still meets it at 3. What about you have limits of 3 as x approaches 4? This is 4 on the x-axis. So to get the corresponding y value, all that you need to do is to trace it towards the graph. When you trace it towards the graph, where does this graph meet with the trace? What number does it mean? It meets it at 3. So that's why we say that limit of a constant number as x approaches any number at all, it is still the constant number. And that is one of the theorems. Please, am I clear?
Yes, sir.
So again, if I have limits of 3 as x approaches -1, the answer is going to be what?
3.
It's going to be 3. So the first theorem we need to have in mind is limit of a constant number as x approaches any number at all. The answer is still the constant number. The next theorem I want to bring on board is this. If I have limit of two functions f of x plus g of x as x approaches a number, it is still going to give me limit of f of x separately as x approaches a plus limit of g of x as s approaches a. That's the next theorem. That's number 2. So meaning when they are together and you find the limit of it, it should be the same as when you split them up and you find the limit separately and you still add them, you get the same answer. Can we take an example for that matter?
Yes, sir.
So if I have, let's say, f of x as, let's say, 2s squared plus 1, and I have g of x, let's say, x minus 1. So it means my function is going to be limit of 2s squared plus 1 plus x minus 1 as x approaches. Please give me just a number to approach. Yes, just 1. Okay, you want to use 1. Now ideally, generally the whole function as we see here, it's a polynomial function. Do you agree with me? But you can go further and simplify, and this is going to give you limits of 2s squared plus x then plus 0 as x approaches 1. For this, we can go directly and substitute because we don't have any undefined solution. Do you agree?
Yes, please.
So that's going to be 2 multiplying 1 all squared plus 1. Final answer is what?
3.
That is 3. Thank you. So again, we can go with when we split it. Splitting it, it means having limit of 2s squared plus 1 plus x minus 1 as x approaches 1. We can split it and write it as limit of 2s squared plus 1 as x approaches 1 or plus limit of x minus 1 as x approaches 1. Do you agree with what I've done there?
Yes, please.
So over here, directly we substitute. That's going to give us 2 times 1 all squared plus 1. And then over here is going to be 1 minus 1. So what do we have here?
3,
Plus what do we have here?
0,
So final answer is what?
3.
3. So they are the same. So that is the other theorem that you should have in mind. Are you with me?
Yes, please.
Any question before I move on?
No, please.
So let's add more to it. Not only plus, but it goes with plus and minus. It goes with plus and minus. So take note of that. Take note of that. Then the next theorem you should have in mind is if you have limit of a function f of x multiplying g of x as x approaches a,
Okay.
you can have it as limit of the function f of x separately as x approaches a. The answer here should multiply limit of g of x as x approaches a. It should be the same. Please, are you with me?
Yes, sir.
So you can take an
Yes.
example to confirm that this is a theorem and it works. So I can use what we just actually, if f of x again is 2x plus 1, this time 2x squared plus 1, and then g of x is actually x, which number did I use? Okay, it was x minus 1. So x minus 1, we can just use that to confirm it. So having limit of 2x squared plus 1 all multiplying x minus 1 as x approaches, let's say 1. Again, we just want to use 1. Ideally, this can be written as direct substitution, right? I hope you can substitute directly. Or you want to expand before you
Yes.
substitute. Okay, so we can substitute
Yes,
directly. So we can have it as 2 multiplying 1 all squared plus 1, then times x, sorry,
1 minus 1.
1 minus 1. Thank you. Times 1 minus 1. So finally, we are going to get 3 here times 0. And that gives us 0. Do you agree?
Yes.
Yes.
So you can do it separately and say that if I have limit of 2x squared plus 1 as x approaches 1, this multiplying limit of x minus 1 as x approaches 1, directly we can substitute. So that's going to give us 2 multiplying 1 all squared plus 1 all multiplying 1 minus 1. Do you agree?
Yes.
Yes.
So this will give us what? The factor here will give us what? Or the bracket here?
3,
3. Multiplying, what do we have here?
0,
0. And therefore you end up getting the final answer as what?
0.
0. Please, are you with me?
Yes, please.
Alright. Okay. So I'm pausing for any question, please. Any question, please? Any question?
No, sir.
All right. If there's no question, then it means I can give you some work to do for me. Are you ready for that?
Yes, sir.
Yes, please.
Okay. So if you are ready for it, let me copy this question for you. Just hold on. Okay, so this is my question. Yes, you remember I shared this file with you to actually go through them. I hope you remember I did that.
Yes, please.
Good. So we'll take some of them, we'll go through them, and then you do the others. I believe you've done certs already, right? Have you done
Yes.
Yes,
certs?
sir.
Good. So this is what I have. We have some few minutes to end the lesson so that in our next meeting we continue. So evaluate each of the following. We'll take some of them and then the others will be done later on. So maybe I can start with question 1, question 2, and it goes on and on and on. So ideally we have, let's start with question. Let me copy 1 to 3 straight ahead. I pray I'll be able to finish this before. Good. So from question number 1, we are to evaluate this. Limit of s squared minus 4 divided by s squared minus 5x plus 6 as x approaches 2. That's how you read it. What answer are we expecting? Now, in the first place, let's ask ourselves some basic questions. When we substitute directly 2 in here, are we going to get an answer or are we not going to get an answer? Let us test with our calculator. Just pick the number 2, plug it in here, and then tell me the final value. So if you have x equal to 2, it means you have it as 2 all squared minus 4 divided by 2 all squared minus 5 times 2 plus 6. Please, what is the answer here? The numerator is 4 minus 4, which is 0. Denominator is going to be 2 squared is 4, and that will give me negative 10. So 4,
0.
so you get 0. So what is the final answer? It is undefined. Do you agree?
Yes.
Good. So it tells you that since you are getting undefined solution, when you plug in the value x equal to 2, then what clue does it that this give you? It gives you that, or it tells you that this function as we have there has a removable what? I made mention of it early on. Yes, it has what? A removable discontinuity factor. It has a removable discontinuity what? Factor. Therefore, our limit of s squared minus 4 divided by s squared minus 5x plus 6 as x approaches 2. We need to write it in a factor form so that we do away with the removable discontinuity factor. So help me out in factorization. Limit s squared minus 4 can be written as what? In a factor form.
X minus 2.
X minus 2 multiplying
X plus 2.
x plus 2. All divided by, let us change this quadratic trinomial to a factor form. Please help me with the factor.
X minus 3.
You have s minus 2 times what?
X minus 3.
X minus 3. For those of us who are not sure of the idea given, x times x will give you s squared. X times negative 3 will give you negative 3x. Negative 2 times s will give you negative 2x. Then negative 2 times negative 3 will give you positive 6. Remember, we had negative 3x, we had negative 2x. When you put them together, you get negative 5x. So our limit of s squared minus 4 is this. The denominator is that in a factor form as x approaches 2. My people, are you with me?
Yes, please.
So at this point,
Yes, sir.
we can do away with the factor which is common for both denominator and numerator. So what is left? We are left with limit of what?
X plus 2.
S plus 2 all over
X minus 3.
x minus 3 as x approaches what?
2.
2. At this point, we don't have any value that will give it undefined because the value of x that we need to substitute in there is what number?
2.
So let's go ahead and plug it in. That will give us 2 plus 2 all over 2 minus 3. Final answer, we have 4 over negative 1, which is negative what? 4.
4.
Please, are you with me?
Yes, please.
Any question on that?
Yes, sir.
No, please.
So can we go to the second question? Or before the second question, let's go to the third one before we come to the second question, which includes a third. Which includes a third. So in this case, we are going to have it as, let me copy that question to another page. So this is what we have here. Just use your calculator to investigate. We have limit of s squared plus 3s plus 2 all divided by s squared plus 4s plus 3. And as s approaches negative 1, when you plug in s as negative 1, what are you going to obtain? Do your investigation before I move on.
Undefined.
It becomes undefined because you end up getting 0 over 0. So it means, what clue does it give you? What clue does it give you?
It means that there's a removable discontinuity factor.
Good. So you need to get rid of that. And hence, you just have to change this into the factor form. So you have limit of, yes, what's the factor for s squared plus
X
3s?
plus 1.
So you have s plus 1 multiplying
X plus 2.
s plus 2. All divided by the denominator to what factors are we going to have? We have x here,
X
x
plus
there,
1.
s plus 1, and then
X plus 3.
s plus 3. As x approaches -1. So we do away with the common factors and we are left with limits of x plus 2 all over x plus 3
Excellent.
as x approaches -1. So we can go
-1.
further to substitute directly, and that will give us -1 plus 2 all over -1 plus 3. Always remember that immediately you substitute, the limit function or symbol does not appear again, and that will give me 1 over 2 as my answer. Are you all with me?
Yes, please.
Yes.
All right. So we go to the third one, the second question. The second question, which is what I have here. So what must we do? Look at it carefully and tell me what we need to do. What do you think we need to do?
You must rationalize the denominator by multiplying 2 by the conjugate of the function of the
Okay.
denominator. Yeah.
Why are you rationalizing, if I may ask?
Because the denominator is a third.
Oh, okay. The denominator is a third. Yes, any other idea? But don't you think that we can? Do you have any removable discontinuity here? Because with this, just plug in the value and let's see what answer you get. Just plug in directly and tell me what the answer is. Meaning, I just want you to try and do it as this. If it is 4, because s is approaching 2. Do you agree? So it becomes 4 minus 2, all divided by root of 2 minus 2. Please, what answer is it giving you?
-2 minus root 2.
So
So,
-2 minus root 2, right? That's the answer you had,
Yes.
isn't it?
Yes.
So in this case, you have gotten an answer. But in the
Yes.
situation whereby you have it as, watch, in a situation whereby you have it as limit of 4 minus x as x approaches 4, sorry, 4 minus x over root of x minus 2 as x approaches 4. This is when you have what we call a removable discontinuity factor, and there will be the need for you to rationalize before you substitute. Please, have you all heard
So please, I
me?
have a question.
Okay, I'm listening.
How do you know if you have a removable discontinuity factor? Do you
Okay,
equate the denominator to 0?
not necessarily equating the denominator to 0, but immediately you substitute the value of x into the function and you end up getting 0 over 0, then it tells you that it has a removable discontinuity factor.
So we should always substitute in the calculator.
Yes, you should always have in mind, do that operation. You should
Okay.
always. But as you just said, if maybe you equate the root of x minus 2 to 0, and then you try to solve for x, you end up getting x root of x equal to positive 2. And solving for x would be squaring both sides, right? So you end up getting the answer as what? 4.
4.
And you know, 4 is what we are supposed to substitute. So it equally gives you the fair idea that immediately you substitute that number into the function, it will give you an undefined solution. So you first have to work out the removable discontinuity factor before you move on. Please, is it clear?
Yes, please.
So per this question, as you see here, when you directly substitute the value of 2 into the function, you get an answer. So there wouldn't be the need for you to rationalize. But per this one, you see that the two questions are different. This one, x is approaching 2, whilst this one, x is approaching what? Yes, x approaching what?
This is approaching 4.
This is approaching 4, but this one is approaching 2. So it means that per this one, there will be the need for you to rationalize before you can move on to work it out. So if the question was to be this, then it means you are going to have it as, please, we are using this, all of you, let your mind be here. So it means you are going to have it as limit of 4 minus x over square root of x minus 2. Then you multiply the numerator by the conjugate of the denominator. Remember, we have as x approaches what? 4. So this one will give us root of x plus 2, and then the denominator will also be root of x plus 2. Going further, that will be giving us, let me get some space. Okay, let me go to another page. Let me copy that and then just move it. So going further, that will be giving us limit of, when you expand this, remember this factor is multiplying everything here. So you get 4 root x, then plus 8,
Plus 8
then
minus
minus
x with
x
x
root x, then
minus
minus
2x.
2x, all on the denominator here will become what? That will give you x, because root x times root x will give you positive x,
Yeah.
and then minus 4. Do you agree with this?
Yes.
As x approaches what number? 4. Have you gotten what is there?
Yes.
When you go further,
Yes.
the numerator now becomes, this will give me,
4 root x.
this and that are ideally 4 root x minus x root of x,
X root x.
then
1 by
minus 2x, then plus 8, all over x minus 4. And remember, the limit sign is the limit as x approaches 4. Let me edit this side. Good. Now, do you know that there's a common factor here?
yes.
And what's the common factor?
The common factor is
Root of
root
x.
x and 2.
So you have it as 4 minus x out, or root x, then minus 2x plus 8, all over x minus 4. Can you go further with it as x approaches 4? Look at it carefully.
Yeah.
What can you do?
Yes. I think you should take negative 2x plus 8. Then factor 2 out.
Okay, so that is also going to give you limit of 4 minus x root of x, then minus 2 out. You have here as what? X minus what?
4.
Plus 4 all over.
No, it's going to be minus 4.
Yeah, it's supposed to be minus 4. Yeah, minus 4 all over x minus 4. Yes, what next?
Then you write root x minus 2 in one bracket, and then x minus 4 in another bracket divided by x minus 4.
But there's a slight difference here. Look at this one and look at that one. So what must we do?
I think with here we shouldn't have factorized negative 2 out. You should just factorize 2. Let's just factorize 2 out. So we have 2 multiplying negative x plus 4.
Or negative 2. Say again.
Positive 2.
You want to make it positive 2?
Positive 2.
And how about this one?
It's going to be negative x plus 4.
Negative x plus 4. Alright, so you want here to be positive. So you have here as plus 2 and here as minus.
And then the x will be negative.
But if you make it positive, watch, if you make it positive 2, it doesn't affect, or it doesn't reflect this.
We bring a negative sign in front of the x. It's negative 2x, so we factor out 2.
Oh, okay. So you have it as negative that and positive that. Very good. And this is the same as limit of 4 minus x root of x. Then you have it as plus 2 into bracket 4 minus x all over x minus 4 as x approaches 4. But remember, at this point you cannot do away with this and that directly.
So you maintain one of the brackets, which is 4 minus x, and then root x plus 2.
So maintaining it, there's still something that you need to do before they can cancel out. If you have it as limit of 4 minus x in one bracket, because that's the common factor for the numerator, the other factor will be root of x plus 2 all over x minus 4 as x approaches 4. As I said, you cannot directly cancel this and that unless you do something to it. What must you do? So that they become the same. What must you do?
Can we factor out negative 1?
Yes, you need to factorize out negative 1 for the denominator. So when you factorize out negative 1 for the denominator, it's going to be limit of 4 minus x into brackets root of x plus 2 all over minus 1 out.
Negative 1.
You have x.
Negative x.
You have negative x, yes. Then plus what? 4.
Plus 4.
As x approaches what? 4. Then at this point, you know that this information is the same as limit of 4 minus x times root of x plus 2 all over minus 1 out into bracket 4 minus x. Does it make sense now?
Yes.
As x approaches 4. So this time around, you can say that the x here, 4 minus x, can do away with the 4 minus x there. And it is left with limit of root of x plus 2
Plus 2.
all over negative 1 as x approaches what number? 4.
4.
So at this point, I believe you know that you can do substitute.
Yes.
And that will give you root of 4 plus 2 all over negative 1. So final answer in all is what?
Minus 4.
Minus 4. So there's a different way of solving this kind of question whereby it has certs in them, and the factor you substitute will give you a removable discontinuity. So in other words, when you have a similar situation like this, always bear in mind you need to rationalize, and this is where your algebra must be very strong. You should know how to factorize out so well before you can get your answers. Please, are you with me?
Yes, please.
All right. Thanks so much for joining the lesson. It's a very great privilege. I'm so grateful for your contributions, and I'm so happy for you understanding the beginning of calculus, which is limits of a function. We are not done yet with limits of a function. There is more to this, but what I would like you to do is that what I've left here, I left some questions over here. Try your hands on them. Practice it, and I believe you are going to be fine. It will interest you to know that they don't ask much questions under limits of functions, but it's actually the basics for calculus. So kindly do more work examples on this, and in our next lesson we are going to look at limits of a function as x approaches infinity, or as the value of s becomes large in a given function.
Please, I have
Yes,
a
please.
question to ask.
I'm listening,
And
please.
basically, you have look at number 5. You have x cubed minus 27. Do
Yes.
you have anything like difference of maybe 3 cubes?
I haven't you done what's the name? We don't have difference of 3 cubes, but I believe you've done something with respect to binomial expansion. Have you done binomial expansion? Binomial theorem. Have you done it?
Yes, sir.
Yeah, so if you've done binomial theorem, there are so many theorems under factorizing x cubed minus 27. And you have to apply those concepts to get this one done. Okay?
And please, I didn't hear you. The network was bad.
Oh, okay. I'm saying that if you've done binomial theorem or binomial expansion, you can use that theorem to factorize out x cubed minus 27 all over x squared minus 9, and you get your answer. Because this one, there's a removable discontinuity, and you definitely need to get it out before you can do your substitution.
Okay.
All right. Thanks so much again for joining. Just try your hands on some of these questions and then give me feedback, and then we all have a nice day. Bye bye.
Okay.